In the following presentation, Professor Dragan Gašević, Professor and Chair in Learning Analytics and Informatics at the University of Edinburgh, explores the growing use of learning analytics in higher education and looks forward to ways in which this powerful tool can best be harnessed to focus on and improve student learning.
I'm going to talk about learning analytics, which is a new field of research and practice. The new field that was basically something called like that for the last 6-7 years. And we are now actually getting to the point that we can start thinking about what are those things that we are doing good, what are those things that we could do better, and what are those things that we don't really do so well and we need to actually start improving and thinking about the ways how we can potentially maximize impact of learning analytics. So this is what I'm going to talk about, is the opportunities for learning analytics to potentially maximize impact. And when I'm talking about impact, I really think about two things, both practice and research. So I'm going to quickly start with the kind of broader context why we at all talk about learning analytics and why we are considering that learning analytics is something relevant. The first thing to consider for learning analytics is really the kind of general trend about the growing needs for education. We are not just talking anymore about broadening access to education, but we are also realizing that education doesn't stop through the end-to-end models that were conventionally available in different higher education institutions, where students would come, take their degree, and then move on forever. There are institutions in the world that are considering actually something where students will be for life affiliated with their institutions or build these types of relationships. There's a vision at Stanford University, which is called Stanford 2025, where they are calling something mission-oriented. Students would come for a year, take the courses and relevant subjects that they think that are important for them for their next mission. For example, to address the problem of water supplies in particular regions of the developed world. They will work on that mission for the next 3 to 4 or 5 years and then return again back to university. Also, from that level of growing needs for education, we also see from the popularity of MOOCs, not that they were, I typically say, quite innovative. They're actually just the surface, the need for lifelong learning, and the profile of learners that was typically assigned or affiliated with MOOCs was something which was quite striking. What we also have is in many universities as well is the need to change our educational opportunities, the way we teach our students. Everybody's talking about active learning, how we can actually have our learners inside of our classrooms more active. Many are trying to use different types of creative methods, for example, flipping their classrooms, preparing lots of online resources for them, coming then ready to the classroom, and then inside of the classroom we are also thinking about different types of clickers. We just discussed before this meeting about that is also used here at the Open University Hong Kong. But many are also trying to be quite creative with respect to their spaces. So for example, try to create flexible spaces, try to use lots of small groups, try to also do many different types of things. But in many cases, whatever we are trying to do, we actually are generously also defunded by our governments in terms of education. So that means really that we need to improve the quality of education. We also need to increase the numbers, yet for less money. So in many cases, we turn to technology as a possible way to deal with scale in many of these issues. Scale is something that can potentially help us to fix something that is at the moment missing or it's quite weak, and those are the feedback loops. Something that when you have a relatively small class, you can then pretty much kind of look into the facial expressions of the people, get some of these social cues, whether people are following you or not, or in many cases, also due to cultural differences, people are just polite and nod rather than basically they are thinking about what you are talking about. But this is really something that with the scale in particular is being completely weakened, and these feedback loops are something that learning analytics is aiming to address. And learning analytics is trying to collect data that are coming and being collected with all these different types of technologies. We have something which has been traditionally used like student information systems. We also have learning management systems, but in all sorts of other technologies that we can think of, whether we are talking about different types of mobile apps, clickers, also different types of social media and so on for different types of purposes that are used. What we are trying to do then is to use methods that are coming from machine learning, data mining, statistics, or social metric analysis that try to then interpret data based on the research that is coming from learning sciences, psychology, or sociology, and then feed that back to learners and also educators to improve their learning performance, learning processes, or the overall learning experience. So what we are also seeing, and this is really one of the most critical things with learning analytics, it's both the field of research and practice. And we are talking about field of practice. We are particularly interested in obtaining practical insights that can lead into actionable knowledge that can optimize learning processes and learning outcomes. When we are talking about theoretical understanding, what we are trying to do, we are also trying to use learning analytics and the types of methods learning analytics offers to broaden our theoretical understanding of learning. In many cases, that could be related, for example, to understanding of self-regulated learning or to understanding of different types of social processes that are shaping the learning experiences in different types of classrooms, or it can be also in different types of online learning opportunities. What we also have with learning analytics is extensive use of data. But data is not something that's new with learning analytics. Data has been used for many years in education, or at least attempted to be used in education. And the best kind of known example for the use of data in higher education is students' evaluations of teaching. And in many cases, what happens with these students' evaluations of teaching, they are static. They happen once our courses are finished. What is the intrinsic nature of learning analytics is longitudinality. So we collect many data points about our learners, sometimes tens, sometimes hundreds, in some cases thousands, and some are claiming even millions of data points about learners throughout their learning experiences. So that's one critical thing. The other critical thing then is, consequently, we actually can get insights into learning or experiences so that our learners are facing in real time. So we are trying to really see what is happening in real time, and based on that, we can try to intervene. But then another critical thing that learning analytics tries to address is it aims to improve the measures that are typically available in higher education. For example, students' evaluations of teaching, they are commonly referred to as the measures of quality. So what we are seeing in terms of actual applications of learning analytics is that we are trying to advance our understanding and support of learning. But in many cases, in the early days of learning analytics, we saw something which I would actually qualify as deficit models, exclusively trying to talk about identification of students at risk and exclusively talking about support for students at risk. There is nothing wrong with that goal. That's an important goal. But there are other equally important student needs. For example, in K-12 sectors across the world, we've been actually finding results that are showing that top 40%, say in Australia, in different types of tests, students are hardly making any progress in any given academic year. Similar types of results are also found in the Netherlands and the UK as well with respect to progression of students. So we are really not focusing at all to all our students and trying to unlock their full potential. So what we are seeing more recently as the focus of learning analytics is the research that tries to explain, describe, and predict different types of learning processes as well as different types of learning outcomes. Also, lots of focus has been on the understanding of learning strategies that learners are following inside of different classrooms, but also lots of focus on the understanding and prediction of different types of 21st century skills or dispositions. And another critical area where learning analytics needs to recognize, and it's been a lot of work done recently, is something related to privacy, ethics, and also infrastructures that institutions need to develop, but also cultural development as well as the overall institutional capacity. So we are seeing a more holistic approaches now in learning analytics and trying to move on from these kind of models that are very deficit focused. So we are also seeing lots of interest in learning analytics. I've been talking to many university vice chancellors or deputy vice chancellors, pro vice chancellors, since we started doing work in learning analytics. I was doing some really exciting things in the past, but nobody really cared about that. Now, really, all of a sudden, you have decision makers, institutions, also IT industry, but you also have other groups that are quite interested, even governments in many cases, where there's really lots of excitement about the learning analytics and its promise. But the question is really, in spite of learning analytics having so much promise and also received so much interest, is it really all that rosy? Are we doing so amazing things that everything's been fixed, or there are certain challenges? And I think there are many challenges in the field. I'm going to really talk today about two specific types of challenges that are critical, in my opinion, for learning analytics to have its healthy development, and in particular to be able to maximize its impact on practice and also research. The first one is validity of our learning analytics and what we can really say and do with learning analytics. And the second one is feedback. What is really there that we can use and also return back to the very promise of learning analytics, and that is to improve our feedback loops between students and teaching staff, as well as between other instances. So let's dive into these two critical challenges. The first challenge is the validity. What do we mean by validity? There are many different dimensions. There's one critical dimension of learning analytics, which is really critical and also has been questioned recently. That's generalizability. The extent to which we can generalize findings that we have in one context in many other contexts. It also is quite related to the extent to which we can replicate some of the results. And there have been many calls recently to try to work more on replications of some of these results. So with respect to that, many actually in the early days felt, well, we have such a great deal of data. Why don't we try to collect data across many different institutions, then based on these huge amounts of data, train beautiful predictive models that can be used everywhere. And there was an initiative that was funded by the Gates Foundation in the US, started in 2011, 12, and 13, and they published some work as well. It was called Open Academic Analytics Initiative. It exactly tried to do that. Try to train the models that were extracted from some institutions and use them in other institutions. It didn't really produce the results that they hoped for. So this is one of the questions. The other one was also more kind of relevant for research, because in the early days in learning analytics, many focused on something which is called social network analysis. And we know that there's a great power of social networks, that people who we talk to are great resources also of information, advice, and help in many cases. But what happened is that we are trying to extract these social networks. We are trying to, for example, understand who is talking to whom, whether we are talking about discussion boards, or in some of our research, we also try to extract which students are taking classes together. And then based on some of these networks that were established, we are doing something which is called social network analysis, trying to understand which students are central in such networks. Who is the central? How many other students, for example, I can access easily? Or how many other students, when they want to talk to some other students, need to first go and ask me to introduce them to them? So what we are getting is, and it's theoretically something which is kind of established, is that those students who are more central are more likely also to have greater success. But research is not consistent. In some studies, we are finding that centrality in networks is indeed significant predictor of student success, in others is not. And then also what we are finding in some cases, it's even negatively associated with student success. So why? Why is that happening? What are those sources? Another critical thing is we are talking a lot about our predictive models. Predictive models will rule the world and they will do everything. But the question is really whether these predictive models are identifying indicators that are relevant for teaching. And there was a study that tried to understand the extent to which the predictive models that were incorporated into something which is called core signals, one of the best known systems in early days related to academic analytics, which tried to identify students at risk and then tried to signal through traffic lights which students were at risk or not to teaching staff. The analysis, follow-up analysis of the quantity of feedback students receive through messages with their instructors, as well as the quality, showed that instructors really didn't improve their teaching at all. So what happened is basically they just increased the frequency of summative feedback. In most of cases, at best, they provided students with merely motivational messages. Oh, you cheer up, you can do it. Rather than really going back to the notions of formative feedback and process feedback, which would actually offer students certain instruction. They also kind of indicated that although this model was very simple, like who is at risk or not, but didn't really offer much insight in terms of why some of these students were at risk or not. There was another critical challenge. There's another thing that was quite associated with the course signal system. Obviously, once you become very well-known, and also lots of media give you lots of attention, then also everybody tries to critically interrogate what you do. So there was a study published at the LUC 12 conference, Learning Analytics and Knowledge conference, which was held in Vancouver in Canada. I happened just to be the program chair, but then the paper in which they also showed the great results in terms of student retention. They followed students of engineering for a period of 5 years, and then they basically found that students who used at least one course signals, they had basically increased student retention for between 20 to 25%, versus students who never took a course with course signals. There were actually lots of criticism of these findings. First of all, because they were actually drawing causal relationships. First of all, the experimental model in which there was actually designed, and the study how it was designed, didn't allow that. Also, the methods that were used didn't really allow for causal relationships to be established. So this was one critical thing. So why we are doing that and the extent to which we are reporting our findings is equally critical. Not directly criticism of learning analytics, but it is quite related really in MOOC research that we are collecting lots of data as well. There was a really nice paper published by Justin Reich in Science magazine a couple of years ago, in which he basically stressed the point that while we are collecting these enormous amounts of data about learners and learning inside of MOOCs, we hardly are advancing our understanding of learning, teaching, cognition, metacognition, and so on. The question is, why is that the challenge? There's even an ethical dilemma that Peter Reimann nicely put in his paper published last year in Learning, Research, and Practice, in which he basically says, is it really ethically valid that we use our descriptions of the past as predictions of the future? And really, in particular, if we are talking in terms of learning analytics, that actually informs our interventions and our teaching and the way how we are changing the context in which we are doing certain things. So the question is that the extent to which we actually can consider validity of our algorithms and the findings that we have and the ways how we can deal with some of these validity issues. Validity is one, obviously, challenge. The other challenge is feedback. So how is feedback provided to stakeholders in learning analytics? I would say in most of cases, what we are seeing with respect to feedback is dashboards. I don't know why we are so fixated to dashboards. Literature on feedback, which predated learning analytics, never mentioned dashboards. Yet, the moment we had data that were associated with learning analytics, all of a sudden, the only possible way for us to think about feedback is dashboards. What do we know so far how dashboards are effective? Well, we know that they can be harmful. There was a study done at the University of Melbourne. They looked into the interpretation of the students of some of these common diagrams that are shown in dashboards, me in comparison to the class average. Even top students, when they saw that they were slightly above the class average, although they were underperforming with respect to their personal goals and prior performance, felt that they were doing okay. When we, and I don't refer here to students, but we as learners, perceive that something is easy in terms of like average score of the course is very high, we even additionally become overconfident and thus study less. So that sends a wrong message. And this is really another critical thing that we need to consider when we are implementing some of these dashboards. There's another challenge as well, is that several studies in the past There's a bit of a change, but a summary was done by the group at KU Leuven of the late Eric Duval. They were actually looking at the dashboards, and they are rarely evaluated. And even when they are evaluated for ease of use. So, I mean, ease of use and the effects on learning or the way how learning processes are improved, they are not quite actually the same thing. So why are we actually not evaluating what matters? More recent studies are improving some of that, but I think there is still a great deal of the work to be done. So I offered a critique, but obviously it would be unfair if I just offered a critique. So I'm going to offer also a bit of a direction as well, and also quite a promise. So it's not really all that bad in learning analytics. There are really many great things. I'm going to give a direction. First critical thing is that we need to consider in learning analytics is that it is about learning. It is not about data science. It is not about beautiful machine learning algorithms. They should be all in service of learning. When I say learning analytics is about learning, I really say that we need to return back to what we already know from our research and practice on learning, teaching, and education. If we think that we are going to invent some of these things with just algorithms, I think we are not going to really be in a good position to do that. Therefore, what I'm actually suggesting for the field of learning analytics that there are equally important additional 2 dimensions to data science. And those are theory and design. With respect to theory, I really think about 2 kinds of theory. Theory that come more from research. They're trying to explain certain phenomena, for example, different types of social learning approaches, or something that comes more from a social constructivist type of approaches that's commonly also referred to in the learning analytics literature, or also another big area is self-regulated learning and different types of models that are commonly used. But then there are also our small theories, like our lowercase theories. They actually come from our practices. They are informing our questions. That is something that is based on the institutional history, that is based on our cultural context, based on which we can also try to hypothesize certain types of questions that is meaningful for a given instructional or institutional context. But then it's equally important design. And design has 3 critical dimensions. The first critical dimension of design is learning design. We know from the literature that our instructional designs are one of the most potent agents in the way how learners are changing their behavior and the way how things are done. We also have, from the respect of design, equally important field of interactive design, in particular interactive design of different types of visualizations. And the third dimension of design, equally important for both research and practice, is our study designs. So the way how we are setting up our experimental setups. Even if it's practice, it's still significant, and we're going to dive and discuss some of these critical dimensions through the challenges. So I'm going to go back to our challenges, but this time with the direction, with some hope and the promise, how certain things can be done. So validity. First and foremost critical thing that we know from educational research is that one size fits all doesn't work. From the individual level, all the individual differences, prior knowledge, our study skills, our motivation changes over time. So what we are motivated in one day doesn't mean we will be motivated the same way, or certain facets of motivation. Also different types of pedagogies that are influencing the ways how we are teaching. Also they are quite influenced with subject domains. But they are equally influenced also with the institutional cultures. And institutions are quite different. They are serving different populations of learners. They are driven by different funding models. They also have certain historical decisions made with respect to technology, with respect to staffing and so on, or the organizational structures that are equally also shaping the extent to which we can use learning analytics and interpret it. This is really one of the critical things with respect to the validity of learning analytics and trying to talk about generalizability. We try to talk about this and the importance of the instructional conditions and the extent to which they are influencing some of our data science and the models that are being developed to predict, for example, learner success. There's another critical thing is why network centrality doesn't work. Well, in many cases, we are not really going back to what theory tells us. And the theory tells us that only those social networks in which we see the prevalence of weak ties is where we are finding also the benefit of being central in such networks. So there are now quite sophisticated data science methods. So I'm not dismissing data science. Data science is great. It offers us methods based on which we can test whether certain networks are built predominantly on weak ties or not. There was a study we were fortunate to conduct at the University of Edinburgh in collaboration with the university out of Uruguay, in which we basically looked into the same MOOC, which was jointly offered by Edinburgh and the Uruguayan University, except that we had two editions of the course. Identical instructional design, one was in English and the other one was in Spanish. What we found is that in one instance of the course, in the Spanish speaking, we had the prevalence of weak ties. In the English speaking, we didn't have. Students tended to cluster more. What we also identify is that in the Spanish speaking course, centrality in networks explained a significant proportion of student success, and it was a significant. In the English speaking course, didn't have any significant effects, and fully was consistent with theory. So the question is why we decide to ignore all this time, this very important theoretical underpinning, when we actually are also trying to inform our theory or our practice with this type of approaches. Once we actually inform it, use very sophisticated data science, we are finding something meaningful. There's another critical thing for us, and that the way we are instrument our learning environments. Well, I'm a software engineer, so I guess I can say a few words about software engineering, right? So how existing data is collected within different types of learning environments is decided primarily by software engineers who have no training in psychometrics or educational measurement or anything else. Initially, they decide to do that just because they wanted to debug their systems and also to have something that can kind of tell them whether their systems worked or not. And that's also been recently used also in terms of, for example, accountability for students when they say system didn't work, but actually it did. And we also have their logins. But then all of a sudden we realize we can potentially use some of these traces as well for understanding of learning, which is fine, except that we really are not advancing our understanding how we can better instrument our learning environments. The first component of that is that we need to incorporate information about our curriculum. What basically specific topics were supposed to be studied? Also, what was the pedagogical intention with respect to some of these topics? If we are not collecting data about this inside of our learning management systems, we are not able then to make meaningful interpretations for some of these decisions, and that's not something that has been done. There's another critical thing is to think about theoretically informed digital traces. How we can actually establish these theoretically informed digital traces. It really is increasing significantly our validity, not only theoretically, but also practically, because we will not be then in the position to defend an instrument for a student's evaluation of teaching, which is not associated with learning as a good proxy of engagement. The work that we did to address some of these challenges is a model that builds on the existing literature and theoretical models on student engagement. So we built on a model that was defined by Rashley and Christensen for student engagement, and it recognizes four critical dimensions of engagement: affective and cognitive engagement, as well as academic and behavioral engagement. But before we are talking about student engagement, we also need to talk about the context. So with context, we are thinking about different types of demographic elements that are shaping our population of students. We're also talking about the classroom and the environments that are related to our classrooms, and we are also talking about individual needs. Then for all these elements of student engagement, what we found were the proxies that were actually based on the interactions of students online. But then also we hypothesized in this model as well, equally, that some of these engagement indicators are mediating the relationship of different types of outcomes and the different types of contextual variables to predict three levels of outcomes: immediate outcomes in terms of what students are at the moment doing and how that can be improved in real time; course level outcomes and post-course level outcomes. And you can also see the dimensions of the outcomes that we are talking about. We're not just talking about the academic outcomes, but you're also talking about different types of social or affective types of outcomes or the types of skills that are relevant. We did a testing of this model. And even with these type of imperfect data that we are collecting at the moment, this model is valid. Our statistical models are actually proving the validity, except that we need to put effort upfront in terms of mapping all these different components of engagement onto the model before we can run some of these statistical analysis. But I believe that this is already giving us a lot of promise in the way how we can measure engagement much more accurately and effectively than what is currently done. There's another alternative approach is that we specifically spend a lot of time working with our software designers and try to identify specific types of learning processes, as well as the interventions that we are trying to introduce with respect to technology, and then trying to think about the ways some of these technological interventions are influencing certain processes. So this is the work that was done by one of my PhD students several years ago, in which she looked into the different types of processes of self-regulated learning and how they were influenced by particular types of interventions that were proved and incorporated in the environment. We then used the graph theory to tell us which of these, first of all, interventions were most important or influential on different types of self-regulated learning processes. What we found is, for example, we called it at the time social way, but that was really an activity stream with workplace learners. It influenced by far the most their planning and also all the phases of their learning than any other intervention that we had in the environment. So in a way that tells us basically that in the workplace, we already knew that it's quite social and quite contextual. And so what their peers and colleagues were doing was also significantly changing things. This is really interesting finding, especially because we were working with a software prototype in which our software engineers very nicely managed to hide this activity stream component, which hardly had any visibility, yet people were very eager to find it and use it inside of the environment. The challenge with this type of approaches is, of course, that we need to spend more time working with software designers, and potentially in the longer term is more expensive than the first approach, which I demonstrated for student engagement. Of course, there are more things that can be done to understand better student engagement and the ways how we understand certain learning processes. And there's something which is called multi-channel or multimodal learning analytics, where some individuals are trying to combine digital traces of learning with something which is like, for example, think aloud protocols or facial recognition or different types of physiological measures that are trying to measure, for example, electrodermal activity and so on, and different types of physiological arousal that are associated with certain types of learning processes. These are highly promising because in the long term, that can actually help us to create much better quality digital traces that are telling us about particular types of learning processes rather than telling us about particular click streams. Validity as well, I challenged with respect to causal relationships. We really need to be very specific whether we are using and what is our study design. If it's something correlational, because the inferences that we can drive from correlational types of studies are very different than based on the causal. The reality is, in practice, at best we can use and also has least ethical concerns is something which is called design-based research. We implement certain interventions and we are doing it iteratively. So design-based research also is trying to do two things. It tries to solve a very practical problem, and also every year is situated in a specific context. Obviously, with respect to design-based research, it's situational, but at least it has a very significant practical value. And if we are consistent with the types of interventions that we are doing also across many different studies, then we are also able to do something which has even some value for research. Another challenge, I don't want to talk much more about validity, is related to feedback and the directions that we have with respect to feedback and the directions. What I'm actually suggesting is that our design of dashboards need to be informed by theory of learning, of teaching, and education. If it's not, then it will not also have any practical impact, as I already indicated. Design needs to do two critical things. It needs to be very specific with respect to what learning mechanisms or processes we are talking about and also needs to refer to the literature. I think the great example of a promising dashboard and also tell us that visualizations are not bad. I'm not suggesting that, but they need to be carefully designed. The work done by Alyssa Wise and her PhD students in a system which is called Starburst. They first of all started from a very practical problem. Many of us are trying to implement online discussions in our classrooms, yet many people are saying, oh, our students are really not participating. Well, very low quality of these, they are very low level of kind of knowledge construction processes and so on. The literature and the theory, and Jerry Stoll's theory of computer-supported collaborative learning is summarizing that students, before they can make meaningful knowledge construction process and engage in that process, they also need to build on the previous contributions of other learners. What we also know from the literature as well is that for many learners, it becomes very hard to catch up with the previous discussions because they don't know what is most relevant, what is not. How they can think which of these scenarios and which of these previous notes, and based on which they can also build their own argument. So in particular, to address this very challenge, they designed a visualization, as you can see, which would give indicators of students what they read and what they didn't, and how they were topically related to each other, these contributions. When they implemented these dashboards in real classrooms, it was considerably improved students, first of all, engagement and reading of the other messages, and in particular those that were most relevant for the arguments they were trying to make. And the other critical thing is also they did an analysis of the quality of the knowledge construction products that students created, and also indicators of knowledge construction processes, which actually were significantly also improved whenever this type of system was implemented. So it really tells us an important story about the critical role of the theory-informed design if we are talking to implement feedback through different types of visual presentation. But there is also another critical thing, and I'm going to challenge again. Why do we think that if it's implemented in learning analytics design, always has to be diagram for feedback? Literature, for example, on theory of cognitive fit tells us that cognitive fit of a particular type of data presentation cannot be generalized, but rather is specific to a particular task. So for example, if a visualization works well to present certain results of some of our statistical analysis, doesn't mean it will be equally well to present results of other types of analysis in other contexts. There's really one critical thing for us to think about. There's another critical theory, and I'm again returning back to the point that I made about the ease of use. Theory of technology task fit tells us that users are happy to accept the increase in the ease of use of their technology, or meaning like technology becomes less easy to use if technology is more useful, especially in complex tasks. And we know that learning is a very complex task that we are actually trying to address. And therefore, when we are designing our dashboards, why we are just so focused on ease of use rather to think about its usefulness to promote learning and to promote better learning outcomes. So this is one of the work that we are trying to do, and the literature as well tells us about feedback that is very specific and tells us that, first of all, the language that we are using in our feedback needs to be task-specific, and secondly, offer guidance to our students. So when I show a dashboard to our students, I hardly use any task-specific language. That's the first thing. The second thing is instruction is hardly existent, meaning that if students are struggling and they already have a certain amount of cognitive load with the task that they are trying to address, if I give them a dashboard which they don't understand, I'm just adding extra level of extraneous load on them that it cannot really be quite helpful for their learning. Therefore, this is really one of these things where we are starting to pose a question. Can we use text as the representation of feedback and also return back to the feedback as feedback? Give me the language that is relevant and also give me the instruction. So this is the work that was initiated by Abelardo Pardo, a colleague at the University of Sydney. We are now working together, in which it was basically suggested that we really need to work on these, first of all, pedagogically meaningful dimensions for any higher education course. In many cases, that's really a week. We have higher education weekly cycles. So learners have certain activities in classrooms and also certain tasks that are given to them. And then the other thing is also we need to think of what those tasks are. What are the indicators of those tasks? How we can then potentially map those relevant indicators for any given task. In our case, we really didn't use any sophisticated data mining. We decided to map these indicators onto quartiles for every given task, or divide students into quartiles for every given task. So for example, task A would have certain indicators, and we would divide students into quartile groups based on that quartile, on that particular task. But then what the instructor was then asked to do was to provide a snippet of feedback for each of these quartiles. So I'm not really talking here about trying to divide students into groups. We are talking about the task and task-specific indicators for learners. So that means that we are not considering learners as a homogeneous group, because students will have 5 or 6 different tasks, and they will not fall under the same quartile in each of these tasks. So that's the first step, and this is the human in the loop. So we are seeing basically the individual will, first of all, identify some of these indicators, provide these snippets of feedback, and then the algorithm will compile these snippets of feedback for every given student. So say a student that is in this particular example, and task 1 was in quartile 1, would get a snippet from quartile 1. Task 2, quartile 3, snippet of that. Eventually, learners were receiving something like this. So learners were receiving a very personalized feedback, also which was offering them guidance. So for example, in some of these activities, they had to watch certain videos. It was a fully flipped classroom with 500 students, approximately. And students were receiving this type of feedback as a formative thing. So we were doing that formatively, exclusively, without really any big stakes for students. But when we observed, for example, a pattern that learner would try to attempt some of these formative or even summative opportunities in the environment in a given week, and we realized they had really many incorrect answers, we also tried to offer them a strategy that they could use to study better. So the instructor said, well, don't watch just the video, but try also to replicate the example that I had in the video and try to resolve it by yourself before you next time try to attempt to take any of these quizzes. This is what we found. We basically measure both the impact on students' grades, but also impact on students' satisfaction with feedback itself. As we know, very few institutions in the world have their students happy with feedback that they are receiving, especially with scale. And so this course had a generally really good course evaluation, but then feedback was relatively low, about 3.2, and 3.2 to 3.3 was something historically stuck flat for many years, right? So we just took the data from 2013, but didn't really change much. In 2014, you see on that diagram, we tried to implement dashboards. Students couldn't care less. They didn't even see it as feedback. Didn't change their perception of feedback at all, right? However, when we implement this type of intervention with feedback that I just indicated, students' basic perception of feedback increased for about half a standard deviation. It went from 3.3 to 3.85. That was the only thing that was changed in the course, and we basically also looked for certain covariates as a potential influence on that. We also even saw some much smaller effect on students' grades. Although some of these students' grades I would not really make the kind of any implication that were caused by this type of intervention, because the effect size was only 0.2 standard deviations. And I'd rather basically have data about students' prior performance. But there are certain ethical challenges why we cannot get access to students' data about prior performance, so we have more robust evaluation of some of these findings. There's another critical thing when we are talking about feedback is analytics and learning design. And what is the role of learning design and what is the role of learning analytics? One critical thing that we need to understand is the moment we put any of the analytics in our environment, our learning design changes. It's not the same anymore because you have some very active agent that is potentially influencing learning. And so we don't really have so much great understanding, as I already indicated, but the really promising work This is again done by Alyssa Wise. And she had an outstanding paper at LAC 14 in which she developed a model that tries to bridge practice and research of learning analytics by trying to bridge learning design and learning analytics. And she saw it, that learning analytics and design, they interact, and the primary goal of the incorporating analytics into our learning designs is to promote the dialogue between students and teaching staff, rather than to actually think about the automating things. Also, analytics is seen in this model as the way how we can promote the agency for our learners, where they see the use of learning analytics as kind of reference frames against which they can evaluate whether their standards and also products of their learning are what they expected or not, and the way how they can better then make their decisions. So this is a quite promising work, and also led into the creation also of that kind of dashboardy tool that I showed about, which is called the Starburst. So I hope I managed to make the argument that learning analytics is not really just about the data science. There are two equally critical dimensions. That's the theory and design that need to be incorporated if you want to maximize impact of learning analytics in both research and practice. These two dimensions are equally important even if we talk about privacy and ethics. For example, Paul Prinsloo and Sharon Slade, they also, when they talked about privacy, they considerably focused on students' agency and the extent to which we are using learning analytics to also increase students' privacy agency, rather us as institutions to make the decisions and patronize students. You are not going to be allowed to actually create a comfortable space for learners to exercise their privacy agency. And there's also a theoretical lens as well. Why in many cases that kind of irrational bit about unknown, such as learning analytics, is in many cases something which is perceived by learners as undesirable, while in some other cases we are seeing that is actually quite helpful once they have the clear rationale and they also are provided with clear examples. Similar discussions and debates are necessary and theoretical foundations if you are talking about, for example, ethics. What is ethical or not? If you don't take critical philosophical and sociological accounts. Equally, design is here quite critical as well when we are talking about privacy and ethics. Which data are we going to show or not? Was it the ethical decision to show data to students when it led to negative outcomes? Even if it was actually possible to theorize that. The moment they told me what they did, I told them it had a negative effect because of particular psychological process. I think that type of thing really needs to be considered even if we are talking about ethics and privacy. But this also tells us about something else as well, that learning analytics cannot be done by computer scientists alone, or by learning scientists alone, or interaction designers alone. It really requires multidisciplinary teams, or teams that are very well connected across the globe, or across different institutions, or across different schools. This is another critical thing for us if we are talking about learning analytics, that we need to embrace the complexity of educational systems, to understand the forces, how they are driving our education, to understand the particular types of factors that are influencing decisions of our stakeholders, and also the role that analytics will play once it's incorporated as yet another node in a very complex network of other nodes inside of our educational systems. I'm going to now thank for your attention and happy to take your questions. Thanks.